Welcome to Chapter 1. Our book is Analytics, Data Science, and Artificial Intelligence, 11th edition. So, an opening example, company Cone, they want to minimize downtime for user suffering, and so their solution, IBM Watson Internet of Things Cloud Performance, to help minimize downtime. Changing business environments and evolving needs for the decision support and analytics. Big bet, high risk decisions, cross-cutting decisions, which are repetitive, ad hoc decisions, and delegating decisions. These are some of the ways that it's used. What is the decision-making process? Define the problem. The decision situation that may deal with some difficult and opportunity. Construct a model that describes the real-world problem. Identify possible solutions to the model problem and evaluate the solution. Compare, choose, and recommend potential solutions to the problem. Other examples is Quain in 2018, 7-step process. Influence of external and internal environments. As we continue on, technology has one of the biggest influences on what we're working with. Government and political, economic, social, and physical, and the environmental. These are all areas that impact what we're working on. How do we deal with AI in this type of environment? Data and its analysis and decision making. Organizations and industry use analytics to develop reports to do the best decision. And it's important to have them timely, proactive, and predictive. And we're going to discuss those in a little bit more detail. Technologies for data analysis and decision support. Group communication and collaboration. Improved data management. Managing big data. Analytical support. Overcoming cognitive limits and processing and storing information, knowledge management, anywhere, anytime support. Simon's process. 3 major phases: intelligence, design, and choice. And as we can see on the chart, understanding what reality is, and then how do we get our intelligence? Organizes objectives, search and scanning procedures, data collection, problem identification, problem ownership, problem classification, and problem statement. This allows us to, if we know what our problem is, then we're able to design a way to find the data, formulate a model, set criteria for choice, search for alternatives, predict and measure outcomes. And the last area is choice. Solutions to the model, sensitive analysis, selections to the best, plan implementation. Once it's implemented, then we can look at, did it work? Collecting data is one of the biggest things right now. There's millions of pieces of data being collected every hour around the world, all about what's going on. Issues that we can have: data is not available. As a result, the model is made, which relies on potential inaccuracies. Obtaining data may be expensive. You don't have it, we have to pay for it. It becomes expensive. Data may not be accurate. Data estimation is often subjective. Data may be insecure. Important data that influences the result may be qualitative. There may be too many data, information overload. Outcomes or results may occur over the extended period. As a result, revenues, expenses, and profits will be recorded at different points in time. To overcome this difficulty, a present value approach can be used in result of the qualifier. It is assumed that the future data will be similar to historic data. If this is not the case, the nature of the change has to be predictive and included in the analysis. These are just some of the issues that we can have when we're collecting data. Problem, design, choice, and implementation phases. Problem, as we looked at before, classification, decomposition, and ownership. design, what models are we going to use, choice, and then implementation. So this is just about understanding that we've got to figure out what we have to do. What is the problem we're trying to fix or resolve with our data? The DSS, the decision support system, the framework, degrees of structuredness, type of control, decision support matrix, computer support for structured, unstructured, and semi-structured data. If we look at the chart, type of decision, structured, operational, central, it could be managerial or strategic. Operation, this is monitoring the assembly line, the accounts receivable, accounts payable, pricing. That is at the front line manager, scheduling, production, controlling. And unstructured data, buying software, avoid loans. When we look at the managerial middle management, they're going to be, for structured data, they analyze the budget, forecasting short term, semi-structured, evaluating credit, preparing budgets, laying out plans, scheduling projects, and unstructured, negotiated, recruiting an executive, buying hardware, and lobbying. Strategic planning, or also top management, they use structured data, manage finances, monitor investments, locating warehouses. For semi-structured data, building new plants, planning mergers, planning new products. And unstructured, planning research development, developing new technologies. This is how each level of management uses the three types of decision support system. Characteristics of capabilities of the decision support system: provide support for semi-structured or unstructured data. 2, supports managers at all levels. 3, supports the individuals and groups. 4, supports interdependent or sequential decisions. 5, supports intelligence design, choice, and implementation. 6, support a variety of decision processes and styles. 7, adaptable and flexible. 8, provides interactive ease of use. 9, improve effectiveness and efficiency. 10, provides complete human control of the process. 11, provides ease of development by the end user. 12, provides models and analysis. 13, provides data access. The last 14 can be standalone, integrated, and web-based. Components of the decision support system: data management subsystem. As we see over in our diagram on the left, we have the three databases: the ERP, point of sale system, legacy, and web. All this comes in across the top: other computer-based systems, internet, intranet, and extranet. The data management, model management, and external models, all this feeds into the main knowledge sub-based systems, user interface, and then the output we get is managers, users, and organizational knowledge base. This is a cloud. It basically all comes together. Everything comes into a central port, and as we need it, we can pull out the information that we're looking for. Model management subsystems: the model base, MBMS, modeling language, model dictionary, directory, model execution, integration, and command process. User interface and subsystem: natural language input. Natural language, if we look up a price, we can say, hey, price lookup, price 64 gig iPhone 10, and we can get a thing. We can also do conversion, $10 US into euros, sports scores and games. Just enter a name in New York teams. Google's SMS will send you the most recent game scores. And this is how we can use the natural language. We don't have to know any coding. We just talk to Alexa or whatever we want, and it understands what we're talking about. Knowledge base management subsystem supports any of the other subsystems or act as an independent component. It provides intelligence and augment the decision makers own or to help understand the use of queries, so it provides consistent answers. evolution of computerized decision support systems. As you can see on the left side, it starts in the 1970s, decision support systems. Decision support systems, AI expert systems, routine reporting. As we move into the 80s, we have enterprise or executive IS systems, enterprise resource planning. Enterprise resource planning is about collecting all the data in one central location to make it easier to find information about. The relational database, the DBMS, becomes popular. In the 90s, early 2000s, business intelligence started. Executive information, dashboards, scoreboards, data warehousing. So in the early 1990s up until 2000, we started collecting this data. How do we use it? Business intelligence, data, text web mining, software as a service. So this has become very popular at that point. In the 2000s, 2010, analytics, social network and media, in-memory database, cloud, big data analytics. In 2010, big data. 2020s were to automation, robotics, smart robo-assistants, AI, deep learning, Internet of Things sensors, automated analytics. This is where we are today with full automation. As you know, AI is making headlines around the world and how it's going to change everything. It's about looking at the data. AI uses the data that it collects in order to predict what's going to happen. Framework of business intelligence, definitions of business intelligence, history of it, and architecture. Now we start out with the data warehouse environment. And this has been around for quite some time. Data warehousing is this collection of data that's not live data. It allows us to analyze the data that's in it. We can run searches and queries on it to figure out what's going on. So data warehouse becomes an essential part of business intelligence. That's where all the data is stored. We have the business analytics environment. That's the users. Users are trying to find that nugget of information that's going to change how we do business. We are looking, where are we? In August, beginning of August. Christmas is only 4 months away. Here's the thing. Back in January, suppliers, manufacturers started building for Christmas, trying to figure out what was going to be selling. What they use, last year's models, today's trends, it all gets put into a computer, into the database, and then the manager's trying to predict how many of something that we sold. Here's the thing. Everything that's going to be for sale at Christmas time is already on ships, ocean freighters coming across the ocean. That usually is a 8 to 12 week process. So all these items that they're here, if they're not already here, chances of getting it now if they leave are slim to none. So this is what companies have to determine. How do we go about where all this data and what to make? As I talked about, data warehouse is a foundation of business intelligence. It's a transactional processing versus the analytic. Transactional processing is the collection of that data. Where did we get that information from? And again, it can be from the ERP system, the legacy system, point of sales, online transaction processing, external data. Where did we get it from? We all put it into this, we select it, we extract it, transform it, we put it into the data warehouse. We have metadata, which tells us metadata is about the data that's in there. Then we're able to look at these little data marts, they're called, and I can say, I only care about, in this case, marketing or operations. I can separate this huge data warehouse, think of it as a mini warehouse. So I'm able to analyze the data for what I want it to be. And then we can dump it out to the applications, to the end users to say, hey, this is what we're trying to do. But we start with the data collection. Where's that data coming from? And that's what makes data, importance of the data warehouse. It's all interrelated. Appropriate planning and alignment with business strategies. A center can demonstrate how BI is clearly linked to the strategy and execution of strategy. A center can serve to encourage interactions between the potential business users and communities of the IS organization. A center can serve as a repository or disseminator of the best BI business intelligence practices between and among different lines of businesses. Standards of excellence in BI practice can be advocated and encouraged throughout the company. The IS organization can learn a great deal through interaction with the users, community, such as knowledge, where the variety of types of analytic tools that are needed. The business community is an IS organization can be better understood on why DW platform must be flexible enough to provide changes for the business. The center can help important stakeholders like high-level executives to see how BI can be appropriate. Analytics. The process of developing an actionable decision or recommendations for actions based on generated for historical data, business analytics. We have three types: descriptive, predictive, and prescriptive. Predictive, descriptive. Descriptive. What happens? What is happening? Business reporting, dashboard, scorecards, data warehouses. Well-defined business problems and opportunities. Predictive. What will happen? Why will it happen? And this is data mining, text mining, web media mining, forecasting, accurate projections of future events. Perspective. What should I do? Why should I do it? Optimize simulation, decision modeling, expert systems, best possible business decisions and outcomes. And this is what makes up all of business analytics. It's understanding that each one of these, what happened, what will happen, and what should I do? These are the three areas that we want to investigate. I talked a little bit about big data. Big data refers to data that cannot be stored in a single storage unit. Big data typically refers to data that comes in many different forms, structured, unstructured, and stream, and so forth. Analytics example is selected domains: sports, business office, healthcare, related. If you just think of all the different areas and how all this goes, even think of the Olympics as we start looking at them with all the data that's being generated. This leads us into a little bit of what artificial intelligence is. AI is based on the theories from several science fields and encompass a wide collection of technology and applications. So it may be beneficial to look at some of the characteristics of AI in order to understand what it is. The major goal of AI is to create intelligent machines that can do the tasks currently being done by people. Ideally, these tasks include reasoning, thinking, learning, and problem solving. Benefits of AI: significant reduction in the cost of performing work. This reduction continues over time, and will cost of doing the same work manually increases with time. Work can be done much faster. Work is consistent in general, more consistent than humans. Increased productivity and profitability, as well as a competitive advantage, are major drivers in AI. Major AI technologies. Knowledge-based. Support theories, tools, platforms, biometrics. These are all different AI applications. The convergence of analytics and AI. The difference between analytics and AI: why combining intelligent operations, big data empowers AI technologies. Overview of the analytic ecosystem. Analytic users in the center. Regulations. What does the government and policymakers say we have to have? Analytic industries, influencers, academic institutions, application developers, data-generated infrastructure, data management infrastructure providers, data warehouse, middleware, data service providers, analytics-focused software. As you can see from the diagram, analytics is in the center. All this information has to come from somewhere. How do we gather this information? What are we doing with it? We apply the rules, and that's the decisions that we need to make on what's going to happen in the future. Then I wrap up, review the thing, complete the homework.